If you also look at that one there, it says very small MV at the bottom, because 1,359.41 horsepower is 1 megawatt.
You are about to hear how a small team in a Swedish factory moved the world of hypercars forward. In one moment of pure emotion, a fresh motor unlike any before, it rose from countless sketches and test benches to a single stage, and its creator could not hold back tears. In the next few minutes, you will learn exactly what makes this new power plant so special, how it fits into the fastest car ever made, and why this day will be remembered. But this wasn't just a reveal. It was a release. Years of pressure, innovation, and obsession condensed into one raw moment. What could move a man like Christian von Koenigsegg to tears? A live moment to remember. Silence fell over the crowd at Koenigsegg's expanded factory in Ängelholm, Sweden, as Christian von Koenigsegg stepped onto the stage to unveil the company's latest creation, the dark matter electric motor. Lights dimmed to a cool blue, and a single spotlight traced the outline of a covered shape at the center of the floor. The cover was drawn back, revealing a compact motor wrapped in gleaming carbon fiber. For a moment, the audience stared, absorbing the sleek form of a machine that promised to redefine electric performance. Christian cleared his throat and began to speak. He described long nights spent poring over drawings, the first test runs marked by sparks and smoke, and the countless setbacks that had nearly derailed the project. He paused as if searching for the right words to capture years of work in a single breath. Then, as he introduced the name Dark Matter, his voice cracked and he blinked rapidly. A tear trickled down his cheek, capturing the stage light and shimmering like a droplet of liquid metal. The audience stared, and for a heartbeat, nothing but soft gasps filled the hall. Cameras in the front row captured Christian's moment of vulnerability, sending live images to thousands of viewers watching online. Social media feeds lit up instantly with clips of the CEO wiping his eyes. People around the world paused their activities to witness the founder moved to tears by his invention. After a brief silence, Christian composed himself and explained the motor's key innovation, a 6-phase raxial flux design that blended the strengths of radial and axial configurations into a single package. He spoke of how the motor delivered 800 horsepower and 1,250 newton-meters of torque, while weighing just 39 kilograms. He described the moment on the test bench when those figures were confirmed and how the team erupted in cheers that echoed through the factory. His eyes shone, not with embarrassment, but with the fervor of someone who had watched an idea take shape against all odds. As Christian walked off the stage, the crowd rose in applause. Engineers and designers embraced, some still dabbing their own eyes. The emotional reveal had turned into a celebration of teamwork and tenacity. Journalists rushed forward to capture the moment, while factory workers lingering behind the scenes exchanged high fives and smiles. Outside, the Swedish sun dipped low, bathing the facility in warm light, as if nature itself approved of the day's achievement. In the hours that followed, footage of Christian's tears became the defining image of the dark matter launch. Automotive analysts praised the technical leap that Koenigsegg had made. While fans admired the CEO's candor and passion, what began as a simple product unveiling ended as a shared human experience, reminding us that behind every revolutionary machine sits a person whose heart beats in time with the motor they create. But to understand why that tear meant everything, you have to go back to the prototypes, the failures, and the raw ambition that first sparked the motor's name. Because before dark matter ever turned heads, it had to defy physics. Birth of dark matter after the moving reveal in Ängelholm. The story of dark matter reaches back to the early days of Koenigsegg's electric motor work. Long before the name dark matter existed, engineers experimented with a unit called a quark. The quark program focused on reinventing how magnets, cooling, materials, and size come together in a motor. It revisited basic ideas about how magnetic fields flow, using a blend of radial and axial layouts that Koenigsegg called raxial flux. Those first quark tests showed promise and taught valuable lessons that led directly to dark matter. The quark motor served as both a learning tool and a stepping stone. It used hollow carbon fiber parts to keep weight low, while strong 300-meter steel gave structure where needed. Inside, direct cooling channels let coolant flow right next to windings, keeping temperatures in check under heavy load. Engineers ran long sessions on rolling benches, measuring torque, speed, and heat every second. When they saw limits, they changed shapes, materials, or fluids. Each issue solved brought them closer to a truly new design. Mixing radial and axial flux in one motor posed new challenges. In old radial motors, the fields move outward to boost top speed. In axial designs, fields run along the axis to boost torque at low speeds. Raxial flux merged these by stacking a pancake-style rotor inside a tube-style stator, then adding 3 extra phases for a total of 6 that gave smoother torque and cut heat spikes. It also lets the motor handle sudden power demands without big cooling packs or fat cables. By the time dark matter took shape, the aim was clear. Build the most powerful, road-leal electric motor in the world, but keep it small and light. The final unit weighs just 39 kilograms and measures only about 38 centimeters square and 13.5 centimeters thick. Yet, it delivers 800 horsepower and 1,250 newton-meters of torque. To reach those numbers, Koenigsegg doubled the usual 3-phase setup, offsetting the extra phases by 30 degrees. The result was silky, smooth power delivery and less heat in peak runs. Materials played a key role in hitting targets for weight and strength. Koenigsegg wrapped both rotor and stator in carbon fiber, cutting a die-hard steel stack for a hollow yet stiff structure. The housing, too, uses forged carbon fiber that keeps spinning parts rock-steady at up to 18,000 revolutions per minute. Instead of stacking thin steel plates, carbon fiber holds magnets and windings tightly, saving dozens of kilograms while resisting extreme forces. Prototypes of dark matter rolled out of Koenigsegg's R&D center. Engineers used 3D printing and CNC machining to make each version fast. Every prototype went to a dyno bench and ran at full power for hours. Teams watched torque curves, current draw, and coolant pressure. If any reading drifted, they paused tests and tweaked designs. Over 1,000 runs later, the motor not only hit its power goals, but also met strict durability targets for heat cycles and vibration. Parallel to design work, Koenigsegg's supply chain team secured custom bearings, high-voltage connectors, and rare earth magnets. They stress-tested insulators against salt spray, humidity, and shake tables. All parts had to fit inside the tight shell of the JRA, with room left for the light tourbillon transmission and the twin-turbo hot V8. This compact layout meant every millimeter and gram mattered in the hybrid system, which would later combine for over 2,300 horsepower. Through each prototype stage, Koenigsegg also took steps to protect its work. The company filed patents for the raxial flux design and the full carbon fiber construction. These filings detailed how the motor combined two flux patterns in one rotor and how the carbon fiber held windings in place. By securing rights before going public, Koenigsegg made sure no other maker could copy their ideas when the dark matter motor hit the stage. Patent protection gave engineers confidence to push designs harder, knowing the design was safe from imitation. This legal effort matched the technical challenges, showing the scope of work behind every part of the motor. Every challenge, from heat to wiring, led to a motor that matched power with reliability. Inside the axial flux design, electric motors usually use one of two setups: radial flux or axial flux. Radial flux motors push magnetic fields outward from the center. Radial flux motors push magnetic fields outward from the center, favoring high speed and power. Axial flux motors align fields along the axis, giving strong torque at low speeds. Koenigsegg's axial flux design merges these two ideas into a single electric motor. By stacking and offsetting components, this approach captures the best of both worlds: high power, smooth torque, and efficient cooling, all in one compact package. At the heart of dark matter lies its six-phase winding. Most electric motors use three phases, with coils spaced 120 degrees apart to create a turning magnetic field. Koenigsegg doubled that to 6 phases, offset by 60 degrees, smoothing torque delivery and cutting out power dips. This 6-phase system also reduces electrical stress, letting the motor run harder for longer without overheating. The rotor and stator of dark matter are both wrapped in carbon fiber. Unlike old steel laminated cores, this carbon fiber shell stays stiff at extreme speeds and keeps weight low. It also holds permanent magnets in place, even as the motor spins past 18,000 revolutions per minute. That stiffness is vital for safety and reliability when chasing peak figures. Inside the stator, cooling channels run directly alongside the copper windings. This direct cooling method pulls heat away faster than standard oil or air cooling. Engineers tested various coolant blends until they found one that stays effective from sub-zero starts through scorching hot runs. This ensured dark matter could deliver full power without thermal limits, cutting performance short. A custom silicon carbide inverter, named David, feeds the 6 phases. Silicon carbide semiconductors handle higher voltages and currents more efficiently than conventional silicon. David weighs just 15 kilograms, but can push over 1,300 amps of AC at 850 volts. By designing both motor and inverter in-house, Koenigsegg guaranteed perfect harmony between the two. The compact shape of dark matter, roughly 38 centimeters by 38 centimeters by 13.5 centimeters, lets it fit inside the Jesco's tight chassis with room for other systems. At 39 kilograms, it is lighter than many 3-phase motors with similar output. That small footprint leaves space for the light-speed transmission and the twin-turbo V8 without stretching the car's length or width. Koenigsegg's engineers ran over 1,000 bench tests on early units. They watched torque curves, current draw, and temperature every millisecond. If any value drifted outside tight limits, the test stopped. Teams adjusted winding layouts, cooling passages, or magnet placement, and retested until they reached full power and repeatable reliability. Merging axial and radial flux meant solving how magnetic fields overlap. Too much overlap could cancel out force, while too little would waste potential. Computer models helped place stator teeth and rotor magnets so that most torque comes from the axial component, with just enough radial boost to raise top speed. The balance makes dark matter both punchy off the line and powerful at high revolutions per minute. Material choice mattered too. Magnets use neodymium iron-boron alloys optimized for high temperature. Insulating resin binds windings and withstands constant vibration. Bearings are custom-made ceramics that spin smoothly at over 20,000 revolutions per minute. Even the smallest clip or gasket had to meet strict weight and heat limits. This full-stack design kept every gram accountable. Putting 6 electrical phases through a single motor raises complexity in wiring and control. Koenigsegg solved this by routing each pair of coils through its channel in the housing. The inverter's software synchronizes currents to fire each coil set in perfect sequence. The result is a seamless, continuous push that any driver can feel the moment they press the pedal. The Raxial Flux design, in dark matter, is more than a clever name. It is a new way to build electric motors that shrinks size, boosts power, and tames heat. By combining 2 proven flux paths, adding extra phases, and using cutting-edge materials, Koenigsegg set a new benchmark for automotive e-motors. Teaming with the hot V8, Koenigsegg paired its new dark matter motor with a modified twin-turbo 5.0-liter V8 to create a hybrid powertrain that offers more than 2,300 horsepower and 2,750 newton-meters of torque in a car with room for 4 adults. This V8 engine comes from Koenigsegg's Jesko model, but it has been altered with larger turbochargers and stronger internal parts to handle higher output. At its peak, it makes 1,500 horsepower at 7,800 revolutions per minute and delivers 1,500 newton-meters of torque at 5,000 revolutions per minute. Unlike a normal front engine, this motor sits behind the cabin and ahead of the rear axle, giving a lower center of gravity and better weight distribution. Around the V8, engineers built the light-speed transmission. This 9-speed multi-clutch gearbox shifts so fast that drivers feel no pause between changes. It uses multiple wet clutches and planetary gears inside a small case. The result is instant power delivery and a direct link to the rear wheels. In front, the dark matter motor provides 800 horsepower and 1,250 newton-meters to the front axle. It works together with the V8 to create all-wheel drive and torque vectoring, which sends the right amount of force to each wheel for faster cornering and better traction. The twin systems share a single prop shaft that runs through the center of the car. That shaft carries torque from the V8 to the front and rear differentials. When the driver lifts off the gas, the car can shift to electric-only mode and coast silently on battery power. In full hybrid mode, both engines work as one unit, managed by a smart control system that balances performance with efficiency. Engineers spent months tuning the interaction between the engine and motor. They tested dozens of software maps for throttle response, region braking, and launch control. Each map tailored how the hybrid system responded at low, mid, and high speeds. The goal was to make the car feel like one seamless machine instead of 2 separate power sources. Fuel flows through a twin-layer system that cools the engine block and turbo housings. Oil lubrication runs through a dry sump to keep the V8 fed during hard cornering. Engineers placed radiators in the front bumper and behind the engine bay so airflow could cool both the engine and the inverter. The dark matter motor uses direct water cooling with channels pressed into its stator. The coolant runs through a loop shared with the V8's intercoolers, removing heat quickly under full power. This shared loop also warms the cabin in cold weather, a useful side effect. Power from the motor also feeds the car's 6,000-watt sound system and 4 screens, preserving battery charge during runs. When the driver hits boost mode, both engines deliver full output, and launch control keeps wheel spin in check. The top speed for the hybrid setup is 400 km per hour, while 0 to 100 km per hour takes just 1.9 seconds. That acceleration makes the Jesko the fastest four-seater ever made. Thanks to the seamless work between the V8 and the motor, the combined system also shines on long runs. The gas tank holds 115 litres, and electric mode adds 50 kilometers of range. Drivers can choose how to split work between engine and motor, balancing fuel use with battery charge as they please. In everyday driving, the motor handles city traffic, allowing silent pulls away from stops. On open roads, both power sources team up for effortless passing and steep hill climbs without strain. Engineers say the link between the V8 and the motor feels natural, with no lag or jerk. Software monitors every second of effort, tuning power split in real time. That intelligence ensures the car always has grip and smooth speed shifts. The hot V8 also grows more refined over time. Koenigsegg offers updates that shift boost thresholds and response curves via over-the-air downloads. This keeps each V8 in peak form as parts age. Together, the engine and motor prove that two different power sources can blend perfectly in one car, offering both blistering speed and everyday ease. This pairing marks a new era where hybrid power means more than just fuel savings. But this isn't just about harmony. It's about raw, record-breaking force packed into elegant precision. So, what kind of specs does it take to make a motor this small feel this unstoppable? Engineering achievements and specs. Every element in Jesko's powertrain shows careful engineering. At its core sits the dark matter electric motor. It weighs just 39 kilograms and still makes 800 horsepower and 1,250 newton-meters of torque. To achieve that, Koenigsegg used a patent-pending 6-phase raxial flux design. Carbon fiber wraps hold magnets and windings in place, shaving unnecessary weight. Direct cooling channels lie next to each winding, drawing heat away fast. These choices let the motor spin beyond 18,000 revolutions per minute without losing power or reliability. The battery pack beneath the floor measures 14 kilowatt-hours at 850 volts. It uses high-energy cells arranged in a flat layout, lowering the center of gravity. A water glycol coolant loop runs through both motor and battery, sharing radiators and pumps. That shared loop also cools the inverter, named David, which uses silicon carbide semiconductors. In-house software manages energy flow at every millisecond, deciding whether to push electric power, charge the battery, or use both systems together. Behind the cabin, a modified 5.0-liter twin-turbo V8 from the Jesko generates 1,500 horsepower at 7,800 revolutions per minute. It produces 1,500 newton-meters of torque at 5,000 revolutions per minute. Engineers lightened the block by using forged aluminum and hollow camshafts, titanium connecting rods, and a low-friction coating on pistons help cut internal losses. Two larger turbochargers feed boost through air-to-water intercoolers, all cooled by the shared loop. This keeps intake air dense and power consistent, even under hard runs. Linking the engine and wheels is the 9-speed, light-speed transmission. Inside its case sits 6 wet clutches and 3 planetary gear sets in a 3x3 layout. Unlike a normal gearbox, it has no synchronizer. When shifting, one clutch pack opens as another closes, which lets the car switch between any two gears instantly. The system also uses a torque vectoring differential that sends power to each rear wheel as needed. On the front, the dark matter motor does its vectoring, guiding grip in tight corners. The weight of the entire system remains low for such power. The motor, inverter, and transmission add under 200 kilograms combined. The V8 itself weighs just 70 kilograms more than the original Jesco unit, thanks to lightweight internals. Even the prop shaft that carries torque fore and aft uses a carbon fiber core with aluminum end fittings. Koenigsegg's carbon fiber monocoque holds everything in place, giving rigidity and safety with minimal mass. Engineers claim the whole car weighs around 2,200 kilograms in its final form. Cooling has been a central focus. 4 radiators sit in the front bumper and 2 more behind the rear wheels. High-flow pumps send coolant through heat exchangers and then into the battery and motor. Brake ducts feed air over ventilated ceramic discs. The rotors measure 410 millimeters up front and 395 millimeters at the rear. 6 and 4 piston calipers clamp each disc, with electric boost assisting pedal feel and reducing fade under track use. Electronics tie every system together. An 80 gigabit per second backbone network carries data between sensors, controllers, and the main ECU. Over-the-air updates let engineers refine shift maps, torque, split strategies, and traction control settings. Real-time logging records every detail when the car is on track. Drivers can download logs after a run, then compare runs and spot areas for improvement. Even firmware for the dark matter motor can be updated without touching a wire. The Jesco's engineering achievements show that when you combine electric and combustion power at this level, attention to detail is the difference between mere speed and a fully usable hypercar. Why it matters. Every innovation in the automotive world must prove itself beyond numbers. Dark matter's electric motor goes beyond horsepower and torque figures. It shows how this car maker can lead in both electric and hybrid powertrains by shrinking size and weight while boosting output. Koenigsegg set a new benchmark that other makers must now match or exceed. This shift matters because it changes expectations across the industry, from supercar builders to mainstream electric vehicle designers. Hypercar performance has always been a race for top speed and lap times. With dark matter, Koenigsegg raised that bar again. The motor's blend of radial and axial flux, plus 6 electrical phases, delivers instant torque and near silence under load. That means 0 to 100 kilometers per hour in under 2 seconds feels smoother and more controllable. It also means track runs can push batteries and electronics harder without overheating. Other manufacturers will watch closely, knowing that a breakthrough this big will shape future hybrid supercar designs. Size and weight matter even in daily driving. An 86-pound motor that makes 800 horsepower fits in spaces where larger electric units could not. This compact form factor gives designers freedom to rethink packaging. Cars with tight cabins or unusual layouts can now add high output without major chassis changes. For customers, it means faster, more efficient models without sacrificing interior space. This trend could extend to luxury sedans and SUVs, where hidden electric boosts add performance without bulk. Beyond cars, dark matter points toward new uses in aerospace and motorsports. Its power density makes it a candidate for electric aircraft, where every kilogram counts. Drones and small planes require motors that deliver more power without heavy battery packs. Formula One teams also seek high-density hybrid motors for future power units. Dark matter shows what is possible today, speeding the path to more efficient, more powerful hybrid race cars. This cross-industry impact underlines why the motor matters far beyond Koenigsegg's factory floor. Electric motors influence sustainability too. By delivering more output per kilogram, dark matter can reduce the size of battery packs needed for the same performance. Smaller batteries weigh less and cost less, lowering environmental impact during mining, production, and end-of-life recycling. Automakers seeking greener methods will study Koenigsegg's methods for carbon fiber housings and efficient cooling. Each step toward lighter, more efficient drivetrains helps cut overall vehicle emissions throughout its life. Patents filed for the axial flux design protect Koenigsegg's work and spur further innovation. Competitors must either license this technology or develop their own solutions. That competition drives research budgets up across the board. New materials, new cooling methods, and new control software follow. In a few years, the result will be broader adoption of multi-phase motors, carbon fiber rotors, and direct cooling channels. Koenigsegg's bold move today accelerates the entire field, making electric motors better for everyone. Koenigsegg also showed that small teams can rival global giants. Major automakers have vast resources. Yet Koenigsegg's team proved that focused expertise and fast decision-making can overcome size gaps. This message encourages other smaller builders and specialty shops to push boundaries without fear. It reminds larger firms that lean operations can innovate quickly, a lesson crucial in a world shifting to EVs and hybrids. The pace of change depends on both ends of the market. Customers will feel these changes soon. As more cars adopt high-density motors, buyers will see faster acceleration and better efficiency in new models. Service networks will learn to handle carbon fiber motors and silicon carbide inverters. Parts suppliers will develop more advanced magnets and cooling systems. Finally, dark matter highlights Koenigsegg's role in automotive history. Past revolutions, turbocharging, all-wheel drive, and carbon fiber monocoques began with pioneers willing to take risks. Koenigsegg now stands among those pioneers, turning concepts into realities that change expectations. Koenigsegg's legacy is already written in carbon fiber and courage. But what about the next chapter? It's being drafted right now, and it promises to shake the foundation of everything we know about performance and possibility. What's next for Koenigsegg? Koenigsegg stands on the brink of another revolution. After the triumphant debut of the dark matter motor, the company plans to turn big ideas into real products that shape the future of high-performance cars. The roadmap ahead focuses on new, limited models, expanded production capacity, deeper work in sustainability, and pioneering pure electric performance. Each step builds on lessons learned from hybrid powertrains, axial flux design, and the hands-on engineering culture that defines Koenigsegg. First on the list is the CC850, a car that honors Koenigsegg's roots while testing new manufacturing methods. Only 100 of these limited editions will roll out, starting in late 2025. By standardizing most options and fixing key performance parts, the team can refine assembly processes and quality checks. This approach speeds up production, ensures consistency, and frees engineers to focus on testing innovations, such as lighter suspension arms and new brake cooling vents. In parallel, the Jesko will gain a hybrid boost at both axles. Registered tests for this update begin in the second half of 2025, with a public reveal scheduled in early 2026. Small electric modules will join the gasoline engine, adding torque vectoring and instant response. Designers aim to keep the battery pack under 15 kilowatt hours, enough for quick sprints while avoiding heavy weight. This evolution will move Jesko from track focus toward a more versatile Hyper GT. On the motorsport side, the CGT concept teases a return to racing. If GT3 or prototype rule changes allow, a Koenigsegg race car could hit the tracks by 2026. Endurance events would push cooling systems, electrics, and safety gear to their limits. Partnerships with tire and brake makers will supply track-ready compounds and pads. The data from racing will feed back into road cars, sharpening performance and reliability for customers. Sustainability drives many projects. Koenigsegg continues tests of e-fuels that burn cleaner in twin-turbo V8s without losing power. Early trials show synthetic fuels can match petrol's energy density in boost conditions. In electric research, engineers are exploring ultra-high voltage battery packs above 1,600 volts. Higher voltage means thinner wiring and faster charging, making electric models lighter and more responsive. Koenigsegg aims to reach carbon-neutral production by 2030, using solar panels on factory roofs and recycled materials in car interiors. Customer experiences will also expand. Following the success of the Ghost Squadron Tour in Europe, Koenigsegg plans similar events in North America and Asia. These tours let owners drive their cars on public roads and test tracks, while engineers collect data on how cars handle heat, humidity, and altitude. Koenigsegg will also offer technical workshops on maintenance, deepening the bond between brand and driver. Digital innovation remains key. Koenigsegg will enhance over-the-air updates, delivering new control maps, suspension settings, and shifting logic directly to cars. A dedicated app will show real-time data on motor health, battery charge, and maintenance alerts. This digital layer means cars get better over time without factory visits. It also lets Koenigsegg respond fast to feedback and roll out new features based on real-world use. Looking further ahead, Koenigsegg may unveil a pure electric hypercar by the end of the decade. This model would use multiple dark matter-style motors or their successors, delivering more than 3,000 horsepower in a lightweight carbon fiber chassis. Early studies on battery chemistry and thermal management are already underway, aiming for over 500 kilometers of range at high speeds. A prototype could appear as soon as 2028. Once Koenigsegg refines ultra-fast charging and advanced cooling, the next generation of leadership will guide Koenigsegg's path. Christian von Koenigsegg works closely with young engineers and designers, passing on hands-on methods through apprenticeship programs. Collaborations with universities and research centers will fuel breakthroughs in materials and control software. This human-centered approach ensures that even as machines grow more complex, the brand's core spirit of passion and creativity remains unchanged. From a tear on stage to a motor that bends the rules of physics, this wasn't just a reveal, it was a revolution. What part of Koenigsegg's journey hit you the hardest? Drop your thoughts below. Until next time, keep chasing the edge.